let's talk about current basics. We use current every day of our life, but did you know there was a time when a steady flow of current and electricity was not even conceived of? Um, Alessandro Volta invented the first electric battery. He discovered that electric current was simply charge passing through a given area over a given time interval. His battery was the first time we had a reliable, controllable current that could be actually used. Now, of course, lightning bolts are a flow of current, but those aren't very safe and they're not very controllable. Now, by definition, current is change in charge divided by time. And our current is measured in amps. Now, you can use a coulomb per second, but let's not. Let's just use amps. Now, remember, protons are stuck in the nucleus. Um, Electrons are what move from atom to atom. Conventional current is set up by the direction that a positive charge would move. They did not realize when they were coming up with these theories that the positive charges, the protons, were stuck in the nucleus, while it was the electrons that were lightly bound to the atoms and could move. So if I say a current is going to the right, that's conventional current. That's the direction a positive charge would move. But we know that electrons are what are really moving, and the electrons are actually moving in the opposite direction. Now, when you flip a switch, there is an electric field set up, and the electric field moves very close to the speed of light. The electric field causes a force that sets the electrons into motion, and this is what causes a current. Now, the electrons are actually moving fairly randomly to start with and colliding with the atoms in the conductor, and they wind up actually moving slowly. It turns out that electrons are very slow, and they move with something called a drift velocity. This is merely the average velocity of the electrons as they travel through your wire. And that's about 2.5 times 10 to the negative 4 meters per second. Think about this. That's about 68 minutes to travel a meter. So the electrons themselves are moving very, very slowly. Now you can think of this like air and wind, okay? Molecules move around very quickly. Air molecules are moving very quickly, but they're not traveling quickly from one place to the next unless you have a breeze. Electrons are moving, but the electricity doesn't travel unless you have an electric field or parallel to the breeze to move them from one place to the next. Now, suppose you have water in a hose. It's not like starting an empty hose where it just, the water's got to chug through and get through. The electrons are already up and down the wire. This is a lot more like having a hose full of water and then turning on the spigot and having the water flow out the instant you turn on the water. Now, sources and types of current. In order to have a current, you must have potential difference. You will not have a current unless you have a potential difference. And remember, positive charges, the conventional current goes from high potential difference to low potential difference. And batteries and generators simply maintain this change in potential. How do they do that? They take other forms of energy and convert to electrical energy. It may be mechanical, it may be chemical. All right? Batteries convert chemical energy into electrical. This lemon is an example of a battery. A battery dies not because it runs out of energy or electrons, because it dies because it runs out of energy, not because it runs out of charge. Chemical batteries are very dangerous, and you need to be careful because those can have some very strong chemicals in them. A generator converts mechanical energy into electrical energy, and it can be, we're going to discuss, it can be AC or DC, and it supplies energy to run appliances. On average, in the United States, our potential difference of a generator is 120 volts. Now we have two kinds of current: direct current, DC, Just means the charges move in one direction. Batteries are always DC. The terminal to fix, positive and negative. You can have DC generators. But alternating current means that the motion of the charges is continuously changing direction. So here I have a charge and it'll move this way for a little while and then it'll go back. It literally vibrates. All right, so the terminals of the potential source are always changing direction. Now it only moves about 10 atoms in each direction. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This one right here will only move about that far. So they're not moving um, very far, but they're vibrating, and that's what's causing our current. And it happens about 60 times a second, so we don't notice the flickering lights. You'll see a lot of your appliances are labeled 60 hertz. We can have generators that are AC, but once again, the generators can be DC as well. Alternating current is what you use, in your home. Direct current is, like your cell phone.